Topic 12. Protection Mechanisms. Part 4. Cryptography. Encryption is the process of converting an original message into a form that cannot be understood by unauthorized individuals. Cryptology, the science of encryption, encompasses two disciplines, cryptography and cryptanalysis. Cryptography, from the Greek word kryptos, meaning hidden, and graphene, meaning to write, describes the processes involved in encoding and decoding messages so that others cannot understand it. Cryptanalysis, from aniline, meaning to break up, is the process for deciphering the original message, or plain text, from an encrypted message, or ciphertext, without knowing the algorithms and keys used to perform the encryption. An algorithm is the mathematical formula or method used to convert an unencrypted message into an encrypted message. A cipher is the transformation of the individual components of an unencrypted message into an encrypted components. Ciphertext or ciphergram, the unintelligible encrypted or encoded message resulting from an encryption. A cryptosystem is the set of transformations necessary to convert an unencrypted message into an encrypted message. Deciphering is decrypting or converting ciphertext to plaintext. Enciphering is encrypting or converting plaintext to ciphertext. A key is the information used in conjunction with the algorithm to create the ciphertext from the plaintext. It can be a series of bits used in a mathematical algorithm or the knowledge of how to manipulate the plaintext. The key space is the entire range of values that can possibly be used to construct an individual key. Plaintext is the original unencrypted message. Steganography is the process of hiding messages, usually within graphic images. Work factor is the amount of effort required to perform cryptanalysis on an encoded message. In encryption, the most commonly used algorithms include three functions: substitution, transposition, and exclusive OR. In a substitution cipher, you substitute one value for another. A monoalphabetic substitution uses only one alphabet. A polyalphabetic substitution uses two or more alphabets. The transposition cipher, or permutation cipher, simply rearranges the values within a block to create the ciphertext. This can be done at the bit level or at the byte level. In the exclusive OR cipher conversion, the bit stream is subjected to a Boolean exclusive OR function against some other data stream, typically a key stream. Exclusive OR works simply. If the two values are the same, you get 0. If not, you get 1. This process is reversible. That is, if you XOR the ciphertext with the key stream, you get the plaintext. Another method used in the occasional spy movie is the use of text in a book as the algorithm to decrypt a message. The key relies on two components: knowing which book to use and having a list of codes representing the page number, line number, and word number of the plaintext word. Specific versions of the Bible are often used as the book in a book cipher. Each of the methods of encryption and decryption described requires that the same algorithm and key are used to both encipher and decipher the message. This is known as private key encryption or symmetric encryption. In this approach to encryption, the same key, a secret key, is used to encrypt and decrypt the message. Symmetric encryption methods are usually extremely efficient, requiring easily accomplished processing to encrypt and decrypt the message. One challenge in symmetric key encryption is getting a copy of the key to the receiver a process that must be conducted out of band to avoid interception. Asymmetric encryption, also known as public key encryption, uses two different keys, but they are related. Either key can be used to encrypt or decrypt the message. However, if key A is used to encrypt the message, then only key B can decrypt it. Conversely, if key B is used to encrypt the message, then only key A can decrypt it. This technique is most valuable when one of the keys is private and the other is public. The problem with asymmetric encryption is that it requires 4 keys to hold a single conversation between two parties, and the number of keys grows geometrically as parties are added. When the asymmetric process is reversed, the private key encrypts a message and the public key decrypts it. The fact that the message was sent by the organization that owns the private key cannot be refuted. This non-repudiation is the foundation of digital signatures. Digital signatures are encrypted messages that are independently verified by a central facility as authentic. A digital certificate is an electronic document similar to a digital signature attached to a file, certifying that the file is from the organization it claims to be from and that it has not been modified from the original format. A certificate authority is an agency that manages the issuance of certificates and serves as the electronic notary public to verify their origin and integrity. Is the entire set of hardware, software, and cryptosystems necessary to implement public key encryption. PKI systems are based on public key cryptosystems and include digital certificates and certificate authorities. Common implementations of PKI include systems that issue digital certificates to users and servers, systems with computer key values to be included in digital certificates, tools for managing user enrollment, key generation, and certificate issuance, verification and return of certificates, key revocation services, and other services associated with PKI that vendors bundle into their products. PKI can increase the capabilities of an organization to protect its information assets by providing the following services: authentication, integrity, confidentiality, authorization, and non-repudiation. Pure asymmetric key encryption is not widely used except in the area of certificates. Instead, it is typically employed in conjunction with a symmetric key encryption, creating a hybrid system. The hybrid process in current use is based on the Diffie-Hellman key exchange method, which provides a way to exchange private keys using public key encryption without exposure to any third parties. In this method, asymmetric encryption is used to exchange symmetric keys so that two organizations can conduct quick, efficient, secure communications based on symmetric encryption. Diffie-Hellman provided the foundation for subsequent developments in public key encryption. While modern cryptosystems can certainly generate unbreakable ciphertext, that is possible only when the proper key management infrastructure has been constructed and when the cryptosystems are operated and managed correctly. For those organizations with the need and capability to use cryptographic controls, they can be used to support several aspects of the business: confidentiality and integrity of email and its attachments, authentication, confidentiality, integrity, and non-repudiation of e-commerce transactions, authentication and confidentiality of remote access through VPN connections, and a higher standard of authentication when used to supplement access control systems. Secure multipurpose Internet Mail Extensions builds on the multipurpose Internet Mail Extensions encoding format by adding encryption and authentication via digital signatures based on public key cryptosystems. Pretty Good Privacy was developed by Phil Zimmerman and uses the international data encryption algorithm Cipher, a 128-bit symmetric key block encryption algorithm with 64-bit blocks for message encoding. With regard to securing web transactions, there are a number of approaches. Secure Sockets Layer, SSL, was developed by Netscape in 1994 to provide security for e-commerce transactions. It mainly relies on RSA for key transfer and on IDEA, DES, or 3DES for encrypted symmetric key-based data transfer. Secure HTTP provides secure e-commerce transactions as well as encrypted web pages for secure data transfer over the web using different algorithms. SSH, the Secure Shell, provides security for remote access connections over public networks by using tunneling authentication services between a client and a server. It is used to secure replacement tools for terminal emulation, remote management, and file transfer applications. Many organizations require use of SSH for these applications. IP security, known as IPsec, is the primary and now dominant cryptographic authentication and encryption product of the IETF's IP Protocol Security Working Group. IPsec combines several different crypto systems: Diffie-Hellman key exchange for deriving key material between peers on a public network, public key cryptography for signing the Diffie-Hellman exchanges to guarantee the identity of the two parties, bulk encryption algorithms such as DES for encrypting the data, and digital certificates signed by a certificate authority to act as digital ID cards. IPsec has two components: the IP security protocol itself, which specifies the information to be added to an IP packet and indicates how to encrypt packet data, and the Internet Key Exchange, which uses asymmetric key exchange and negotiates the security associations. IPsec works in two modes of operation: transport and tunnel. In transport mode, only the IP data is encrypted, not the IP headers themselves. This allows intermediate nodes to read the source and destination addresses. In tunnel mode, the entire IP packet is encrypted and inserted as the payload in another IP packet. IPsec and other cryptographic extensions to TCP/IP are often used to support a virtual private network, a private secure network that is operated over a public and insecure network. A final use of crypto systems is to provide enhanced and secure authentication. One approach to this issue is provided by Kerberos, which uses symmetric key encryption to validate an individual user's access to various network resources. It keeps a database containing the private keys of clients and servers that are in the authentication domain that it supervises. Kerberos is a system that knows these private keys and can authenticate one network node to another. Kerberos also generates temporary session keys, that is, private keys given to the two parties in a conversation. Kerberos consists of three interacting services, all of which rely on a database library. These are the authentication server, the key distribution center, and the Kerberos ticket granting service. Some important rules for managing cryptographic controls. Don't lose your keys. Know who you are communicating with. Realize it may be illegal to use a specific encryption technique when communicating to some nations. Note that every crypto system has weaknesses. Give access only to those with a business need. And when placing trust into a certificate authority, ask yourself, who watches the watchers? Also note, there is no security in obscurity. Security protocols and the cryptosystems they use are installed and configured by humans, and thus they are only as good as their installers. Finally, as with all other information security program components, make sure that your organization's use of cryptography is based on well-constructed policy and supported with sound management procedures.